Hello friends, our today topic is relation and functions. Difference, as you know that our unit first is running and we are discussing unit first one by one topic, and that is main title is discrete mathematics. A binary relation R from set x to y as written look here is a subset of the Cartesian product x into y. If the ordered pair of G is reserved, the relation also changes. Generally, an array relation R between set A up to An, as this is shown here. The minimum cardinality of a relation R is 0 and maximum is n to n. In this case, a binary relation R on a single set A is a subset of A into A. As you see here, domain and range. If there are two sets A and B, and relation R have order pair x, y, then the domain of R, dom R is set as shown here, the range of R as shown here. These are the examples. You can look here and understand here. Next is representation of relations using graph. A relation can be represented using a directed graph. The number of vertices in the graph is equal to the number of elements in the set from which the relation has been defined. For each ordered pair xy in the relation R, there will be a directed edge from the vertex x to vertex y. If there is an ordered pair xx, there will be self loop on vertex x. Suppose there is a relation R1, these are the sets 1 1 1 2 3 2, and the relation is 1 1 1 2 3 2 on set S 1 2 3. It can be represented by the following graph as shown here. Look here. Now we are discussing about the types of relations. The empty relation between set x and y, this is represented by this type of symbols. The for relation, the identity relation, these are the examples. A relation R on set A is called symmetric, as this is shown here, symmetric relation. These other are also the same example of it. And coming to the next topic, a function. A function or mapping defined as f colon x implies y is a relationship from elements of one set x to elements of another set y. X and y are non-empty set, and x is called domain and y is called codomain of function f. Function f is a relation on x such that for each x implies x, here exists a unique y such that x y implies relation xy is called a pre-image and y is called image of function f. A function can be one to one or many to one, but not one to many. Please be note that a function can be one to one, हो सकता है वन टू वन और मैनी टू वन, but it cannot be one to many. Be note, and it's a very important point. Okay, we have cleared it. Next is injective one-to-one function. As f colon a implies b, it is injective or one-to-one function if for every b belongs to b there exists at most one, as this is shown with a simple example. Next is surjective onto function. This is shown here. And next, coming to the bijective one-to-one correspondent, it's also here. You can look here. A function f implies a bijective or one-to-one correspondent if and only if f is both injective and surjective home. That can be a bijective functions. Inverse of function. The inverse of a one-to-one corresponding function is the function, this is g graph for this implies that holding the following property x implies x y such that gy is equal to xf x y such that gy equal to x. A function f is called invertible. It is only functions g exist. Composition of function. The two functions, this is as represented here, can be composite to give a composition. This is the group A to C defined by this. Look here, this is the example and this is the solution. You can look here. Some fact about composition: if g are 1 to 1, then the function g o f is also 1 to 1. If f and g are 1 to 1, if f and g are onto, then function g of is also onto. Composition always hold associative property but does not hold commutative property. Understand it clearly? I hope you understand very clearly. So this was like our today class, functions and relations. I hope you understand each and every points. So if you like our today video, please like, share with your friends and subscribe our channel and bell icon for the coming videos. Thank you very much.